Hello dear students, welcome to another interesting session at brilliantmaths.com. We are actually continuing our lessons on trigonometry, so get your copy of Brilliant Maths Module 6 and let's go to class. In this lesson we are looking at trigonometric ratios and we want to be able to draw the sine curve. We talked about the sine ratio, the cosine ratio and the trig ratio. So here we're drawing the sine curve. The example is draw the graph of y is equal to sine theta for the range of theta between 0 and 360. So we want to see what the sine curve looks like in the different quadrants. So to draw a graph, the first thing you do is you plot your table of values. X is the independent variable, and which is theta in this case. The values of theta from 0 to 360. So we take intervals of 30 degrees. And then we find the corresponding y values, which will be the sine of those angles. So as we can see from the board, when theta is 0, sine 0 is 0. Sine 30 is half. Sine 90 is 1. Sine 150 is 0.5, which is also half. Sine 210 is 0.5, but can you see that sine 180 is 0? And then we'll plot it all the way to the fourth quadrant, which gives us a complete revolution of 360 degrees. So let's try to plot that. We have the quadrants on the board. That's our y-axis, which is our sine theta, and the x-axis, which is theta. So theta is 0, and sine theta is 0. So the point is right here. And then, when theta is 30, sine theta is half. So that's somewhere here. When theta is 60, is almost 0.9, but when theta is 90, it is 1, right on the dot. So sine 90 degrees is 1. 150 is 0.5. That's 90 plus 3 is 120, so this is 150. So it's back to 0.5, so somewhere there. And then sine 180 is 0. Sine 210 is minus 0.5. You can see that sine has entered into the third quadrant where it is negative. We saw that in one of our previous lessons. If you haven't seen that video, go and look for it. Sine 210 degrees is 0.5 negative. So 210, 180 plus 30 would give us 210. So we have the point somewhere there. Then sine 270 degrees is minus 1. Minus 1 is right here. And then sine 330 degrees is minus 0.5. 330, it's somewhere there. So 0.5 minus is halfway between 0 and 1. And then 360, sine 360 is 0. So that's the sort of curve that we have. Let's attempt to join the curve. So we have, it flows, yeah. That's a sketch of the sine curve. All the points should be on the curve. As you can see, the sine curve, it starts from 0, goes up to positive 1, which is the highest point on the curve, and then it begins to descend. After 180 degrees, it has gone from 0 to 1 and back to 0. And then it descends into the negative axis, where we have from 0 to minus 1 and then back to 0. So the highest point on the sine curve is 1, and the lowest point is minus 1. I'd like you to plot this in your graph book. Try to plot it out so you can actually see that. And then try out the cosine curve. Try out the cosine curve so that you can see how it behaves. Does it behave in the same manner? What is cos 0 and what is cos 90? That is where you would see the difference. Let's look at another example. In this next example, we want to draw the graph of y is equal to sine x plus cos x. Values of x from 0 to 360. So let's look at the example. Example, draw the graph of y is equal to sine x plus cos x for values of x from 0 to 360 using intervals of 60 degrees. Then use your graph to find A, the values of x correct to the nearest degree, for which sine x plus cos x is equal to 0.75. B, use your graph to find the minimum and maximum values of y, stating the values of x for which they occur. So solution, you draw the table of value for values of x from 0 to 360, then values of sine x from 0 to 360, and also the values of cos x from 0 to 360. Remember, our intervals are in 60 degrees. Then you add the values of sine x plus the values of cos x. So that will give us our y values. So the x values will be the 0 to 360 values of x, and then the y values will be the sum of sine x and cos x. So the final table of value will be x and y. And x will be in intervals of 60 from 0 to 360, and then y will be in the sum of sine x and cos x. So that is what we have plotted on the board. Let's look at it. So that's the graph of y is equal to sine x plus cos x. When x is 0, y is 1, as you can see from the table. When x is 60, y is 1.37. When x is 120, y is 0.37. When x is 180, y is minus 1. When x is 240, y is minus 1.4. When x is 300 degrees, y is minus 0.47. And then when x is 360 degrees, y is equal to positive 1. So that gives us the curve, the graph of sine x plus cos x. And then we were told to find the value of cos x plus sine x, which will be equal to 0.75. So you draw a line equal to 0.75, y equal to 0.75, and see where it cuts the graph. And those are the values of x for which that occurs. So we look at the point where it cuts the graph. At this point, and at this point. What are the values of x. From the graph, the x value, the first x value when the sum of sine x and cos x is equal to 0.75 will be 102 degrees. So x is equal to 102 degrees, or x is equal to 348 degrees. At those two values of x, sine x plus cos x is equal to 0.75. The second question says, find the minimum and maximum values of the graph and the points at which they occur. So the minimum value of the graph is at y is equal to minus 1.4, and that occurs at x is equal to 225 degrees. And the maximum value is positive 1.4, and that occurs at x is equal to 45 degrees. Take your time and plot out this graph. You'll actually see that it's very easy. Use your calculator to find the values of sine x and cos x and add them together. You'll find out that you can do it. In this part of the lesson, we want to learn how to solve problems involving trigonometric ratios. A ladder 13 meters long stands on horizontal ground, leaning against a vertical wall. What does that mean in real life? So we have a ladder that is leaning against a vertical wall. So that's the vertical wall. And then we have a ladder leaning against the wall. So the ladder is 13 meters long. So that's our ladder there, is 13 meters, and that's the wall. Then it says the ladder makes an angle of 50 degrees with the ground. So that's the ladder. The angle it makes with the ground will be on the floor here. So that's the ground. And the ladder makes an angle of 50 degrees with the ground. All right? How far is the foot of the ladder from the wall? Remember, this is the wall. And then this is the foot of the ladder. So we have to find this length, x. We have to find the distance between the foot of the ladder and the vertical wall. So what do? We have 13 meters. We have 50 degrees, and we're supposed to find x. What ratio should we use? That is the hypotenuse, because it's the right angle triangle. The wall makes 90 degrees with the ground, of course. So if we have 50 degrees, and we have the line, we're supposed to find the line adjacent to the 50 degrees, and we're given the slanted side, which is the hypotenuse. So the relationship between the angle and the sides given is adjacent over hypotenuse. So that means we are using the cos ratio. So cos 50 degrees is equal to adjacent A over h, which will give us x over 13 meters. So to find x, which is the distance between the foot of the ladder and the wall, x is equal to cos 50 degrees times 13 meters. So put that into your calculator, and what would you get? So we have 13 times cos 50 degrees. And that will give us 8.36 meters. So x is equal to 8.36 meters. X is approximately 8.4 meters. So that tells us that the distance between the foot of the ladder and the vertical wall is 8.4 meters. You can actually try this out at home. Get a ladder, measure the length of the ladder, put it against a wall, and find the distance. The distance between the foot of the ladder and the vertical wall. That is real-life maths for you. In this part of the lesson, we want to learn how to work with the sine rule. We will not bother with the proof. We will just work with the rule. Example 1. Calculate the length of x. The sine rule is used to find length of sides or value of angles in a triangle where you have some of the angles and some of the sides given. So you will determine when to use the sine rule or when to use the cosine rule, depending again on the parameters that have been given. So for example 1, we have a triangle and we have 2 angles and 1 side. And then we are supposed to find another side. So the sine rule states that the side over the angle. So first, let's learn how to label the triangle to be able to use the rule. The angles will take the capital case, the uppercase letters. So let's say this is triangle A, B, C. The angles will take the uppercase letters. The side opposite the angle will take the lowercase letter of that angle. So that's angle B. So 13 is opposite angle B. So that will be our side B, lowercase b. That's angle A. The length opposite that angle will be lowercase a. And then angle C, the side opposite angle C will be lowercase c. So that the ratio of side A over the sine of angle A will be equal to the ratio of side B over the sine of angle B, and that will be equal to the ratio of C over sine C. So then you put in the values of what we have been given. Our A is not known, and our sine A is also not known, so we do not need to use that. What is side B? B is 13 centimeters over sine B is 95 degrees. And that is equal to C, which is the side we are looking for, x over sine C. And C is 20 degrees. So that would be sine 20 degrees. So to find the length of x, we simply cross multiply. So sine 20 times 13 centimeters over sine 95 degrees will give us the value of x. So x is equal to 13 times sine 20 degrees over sine 95 degrees. So we'll put that into the calculator to be able to find the length of AB, which is not known. So 13 times sine 20 degrees, and then we divide that by sine 95 degrees. And what do we have? X is equal to 4.46 centimeters. X is equal to 4.46 centimeters, which is approximately 4.5 centimeters. All right, let's look at example 2. Example 2, we have a triangle, triangle ABC. And the question is to calculate the size of angle ABC, that's the angle at B. That angle is not known. And the length of A. As we can see, the triangle has been properly labeled so we can apply the sine rule. Angle A and line A, opposite. Angle C, an opposite angle C, we have the side C. An opposite angle B, we have the side B, which is 61.8 millimeters. So solution, the first thing we want to do is to find the size of angle B. And it's a triangle, and the sum of the angles of a triangle will add up to 180 degrees. So ABC, the angle at B, is equal to 180 degrees minus the sum of angle A and angle C. And A plus C will give us 114 degrees. And if you subtract 114 degrees from 180 degrees, 10 take away 4 is 6. We have 7 there. 7 take away 1 is 6. And 1 take away 1 is 0. So we are left with 66 degrees. That means that angle B is equal to 66 degrees. So the next question is to find the length of A. So using the sine rule, A over sine A is equal to B over sine B. A is the length we are supposed to find. So we have A over, angle A is 42 degrees, is equal to B. The line B is 61.8 millimeters over sine B, and B is 66 degrees. So you take out your calculator and put in the values. How do we find A? We simply cross multiply. So A is equal to 61.8 millimeters times sine 42 degrees over sine 66 degrees. And what would that give us? So let's find out. 61.8 times sine 42 degrees, and then divided by sine 66 degrees. And that's equal to 45.27 millimeters. So that is 45.27. So approximately 45.3 millimeters. So that tells us that the line BC is equal to 45.3 millimeters. So take your time to work it out. It's actually very easy. All you need to do is work step by step. And for more of this, go to Brilliant Maths Module 6. I hope you enjoyed today's lesson. I'm very sure you did. Subscribe to brilliantmaths.com and you will be on your way to becoming an excellent student in math. And always remember, maths is fun and you can excel in it. Follow us on all our social media handles. My name is Ngozi Orevogene. See you again soon.